Good morning. Today's lesson is on parametric equations. So what you should get out of this, you need to know what are parametric equations for a particular equation. You'll have to graph them, be able to use the parametric equations to graph, and rewrite parametric equations as a rectangular equation. So every time you've had an equation prior to this, they've always been in terms of x and y. So what we're going to do is we're going to introduce another variable. And this third variable that we're going to introduce for right now is going to be t for time. So let's look at this equation or this problem here. It's saying the initial velocity of an object is 48 feet per second. It can be shown by this parabolic path. So it gives you a rectangular equation. So a rectangular equation is an equation that's written in x's and y's. So what we're going to do is we're going to take that rectangular equation and we're going to rewrite it in terms of parametric equations. So parametric equations is talking about what's happening over time. So if you look here at time 0, we're at the origin. Whereas over here at time 3 square root of 2 over 4, we're located at 3618. And at 3 square root of 2 over 2, we're at 72. So we're rewriting these equations in terms of t. So when we are doing this, notice that the x equals 24 square root of 2t is called a parametric equation for the x. And we also have a parametric equation for the y, which is your negative 16t squared plus 24 square root of 2t. So really what happens is if we took the equation here for x and we solve for t, and we replace that into the y, we should get our rectangular equation, which is what they're going to have you do, is to switch from parametric equations to rectangular equations. Now, from those equations, though, we can still figure out what's going on in terms of time. So at time of 0, we got that we were at the origin. We were at 0, 0. At time of 1, we see that we're at 24 square root of 2 and 24 square root of 2 minus 16. And you can keep plugging in different values of time into those parametric equations to figure out your location. So if your two functions are continuous of time on a certain interval, then they have parametric equations. That's what the f of t and g of t are representing, the parametric equations. So f of t, g of t is a plane curve C where the equations are x equals f of t and y equals g of t. And those represent your parametric equations. So there are several videos on the parametric equations. So please make sure that you watch those videos. If you need any help or we need to go into this any further, please let me know. I would be happy to help. Have a great day.